Hi, welcome to the Math differential equation problem solving section. So today we will try to solve this differential equation dy dx equal to the 1 over x minus ey with the initial condition y1 equal to 0. This one looks pretty easy, but I think this is the first order nonlinear differential equation, and the whole equation is very simple, but I think the method for solving it is kind of like a little tricky here. All right, so let's get a start. Okay, so as always, if you have any other easier way than the way I solve it, please feel free to leave a comments in the, my site, and I like to learn about that. Okay, so for this one, this is the first order differential equation, nonlinear, because I have EY's layers, right? So we said the nonlinear one with typical the method we can use is the separate variables separation, substitution, or use the exact differential equation or the integration factor. So for here, I think maybe the use the substitution probably would be easy because I did try the other method like the exact differential equation, try to separate the variable. It's not successful. So that's why I'm going to use the substitutions here. All right. So let's go ahead and start. So first substitutions here. I'm going to set u equal to, because this x minus ey really is kind of about me. So I will change it to a simple one. U is equal to, the x minus ey. Now I take the derivative of both sides. So I will have du, okay, over dx is equal to 1 minus ey dy dx. So like we did the substitution before, I want to find what is the value of dy, so then I can plug it into my original equation here. All right, so let's go ahead. So this one's here will give me the dy dx will be equal to, so here, don't skip the step here. All right, so here I would say this is the ey dy dx is equal to the 1 minus du dx. All right, then you want to find the dy dx is just going to be equal to 1 minus du dx over E1. Okay, and now in here, because this is my u equal to the x minus u, I also wanted, so this one, I can also say the ey is equal to the x minus u. Okay, so I'm going to highlight those, so just in case later I'll need to use this information, I can find it. Okay, so now I find my dy dx here. I find my dy dx. Now I'm going to substitute to here the dy dx here. All right. So the dy dx is equal to 1 minus du dx. So it's 1 minus du dx over ey is equal to 1 minus x minus ey. Okay, so now I times ey both sides. So it's 1 minus du dx will be equal to ey x minus ey. Okay, so this is x minus ey. So now I can find my du dx. The du dx will be 1 minus ey x minus ey. So now I want to change this to u, okay? So see here, this is 1 minus ey is x minus u, and x minus ey is u, so this is equal to u, right? Okay, so now I will try to combine these two. Common denominator is u, so it's u minus x minus positive plus u. So it's going to be a u, the 2u plus x. And I'm sorry, not a plus, it's a minus here, right? 2u minus x. 2u minus x, and then this will be equal to the 2 minus x over u here. All right, so du dx. Okay, so now, so let's say this is I like to mark it step number 1 so we don't get confused. Okay, step number 2, let me highlight this. We finally find u and x, right? So du dx is equal to 2 minus xu. All right, so 2 minus xu, well, still it's not very helpful for the 2 minus xu's here. So I'm going to do another substitutions here. So let me put this one here. So du dx is equal to 2 minus x over u. So here I will switch 2 minus x over u. It's 1 minus u over x, right? So 1 over u over x is here. So now, okay, you will see why I want to do that. So now I will set another substitution. Let's say v. I will say v is equal to u over x here. All right. So now in here I can say u is equal to v times x. So right now my goal here is to try to replace the du dx to be a dv dx. Okay, so now I take the derivative of x. So du dx product rule, right? So the product rule will be dv dx times x plus, the plus v times 1. Okay, so let's, so du dx is equal to here. Okay, so let me highlight here so you know where I'm going. All right, so here this is du dx here, and I just find this, right? So now I will substitute the du dx. So I will say the dv dx times x. All right, so dv dx times x plus v is equal to 2 minus u over x. U over x. U over x is v, right? So it's 1 over v. Okay, 1 over v here. Okay, so now I can put everything for the, the v, in one side here. So this is the, so I will say here. Okay, so here, okay, let me go to number 3. So give it some space here. All right, so this is dv. Okay, so now here, all right, so here, just do one step at a time. So I have a dv dx times x is equal to 2 minus 1 over v. And I'm going to move this one to the right-hand side. Okay, so 2 minus v minus v here. Okay, so then I can find the common denominator. So this is v, then this is 2v minus v. All right, so 2v minus 1 minus 1 minus v squared. That's right. Okay, so now I can have v, I have v squared minus 2v plus 1. Okay, so I can finally change this one to be a v minus v minus 1 to the square. All right, so the du d, so we have a dv dx, the x is equal to the negative u v minus 1 squared to the v's here. Okay, so now let me rewrite these equations here. So just in case this is what we did so far, right? So here we did is we find that this one equal to here. As you see here, now what is the beauty happens here? Let me rewrite this. This is a dv dx to the x equal to negative v minus 1 to the square, right? So now you see I can do the variable separation. Wow, that's pretty good. So now I know I find the answers here, right? So move the dv all to here. So I can say here, so you times negative v, right? And this is v minus 1 square is equal to, then move the x over, so it's 1 over x dx. You see here, so from here to here, I'll be able to use the variable, finally, variable separation after 2 substitutions, right? So now we can integrate. Now the number 6 here is integrate both sides, right? So I can integrate both sides here because I did a variable separation. That's what the whole things I want to do, right? So it's pretty cool. All right, so now I integrate both sides, and my right-hand side is pretty easy. All right, so my right-hand side is here. This is going to be a natural log x, okay? And plus c, all right? Then now this one's here, I'm going to do is negative v minus 1 square dv's here. Okay, all right, so I'm going to take this one out and do it, and then I can plug it back in. All right, so now I'm going to take this one out, try to do the integration. All right, so this one's here. Okay, so I'm integrating negative v minus 1 square dv. I can do this by the integration by the partial fraction. So I can separate this one into the v minus 1 to the a dv plus to this. All right, so the plus b, then v minus 1 to the square dv, right? That's the partial fraction. And then I can try to combine. So this will be equal to v minus 1 to the square. So this is a to the v minus 1 plus b. That's right. Okay, so a to the minus 1. So I have av minus a plus b right on the top here. Okay, so maybe don't skip anything. So dv is right. So I will have here, this one's here is v minus 1 to the square, av minus a plus b dv's here. All right. Now I know this is negative v's, right? So okay, so this one's here. So because the v terms here, okay, so here the v term only have a, then here the v term is negative 1. So what do we have here? So I will find the a equal to negative 1. right? Then the b term is 0, so now the b term is 0, the remaining is b minus a is equal to 0 because there is no constant term, right? So that's why we know the b is equal to -1 as well. So this is what we learn in the partial fractions, right? Partial fractions integration. So now finally, this I'll be able to do is -1. Okay, so this is a -1 v minus 1 dv. Then plus, take the derivative, -1 v minus 1 the square dv. So this one here is a natural log, right? So this will be the negative natural log of v minus 1, okay? Then plus this one, I can use the the power rule, right? So it's v minus 1, the -2, so it's -2 plus 1, v minus 1, the negative plus 2, so it's -1 plus negative is positive. So this one will give you 1 over v minus 1. Okay, so that's it, right? Okay, so now that's okay, so this one's here now. I be able to, let me put the color codings here. That means this one's here. I will be able to substitute back to what we here, right? So that equation. So what do we have is here? So we will have a natural log. Let's put a 7. So this is a natural log ln v minus 1 plus 1 over v minus 1, right? So here the yellow match yellows, right? Is equal to the natural log x plus c. All right, plus c. So what is my initial condition? Y1 equal to 0. Okay, so y1 equal to 0. All right, so now I need to substitute back to my functions here. So next negative ln. What is the v's here? All right, remember we said we need to know the v's here, right? So the v, where is v is u over x. Okay, good. V is u over x. So I have u over x minus 1 plus 1 over u over x minus 1, right? Because v is, so it's equal to the natural log x plus c. Now, what is my u? Let's go back to my very beginning. What is my u? Is x minus ey. All right, u is x minus ey. Okay, so finally, I can say it's negative ln. So x, so the u is x minus ey minus 1 plus 1 over x minus ey minus 1 and equal to the natural log x plus c. Okay, so now I will plug in my, all right, so now I will plug in my initial condition y1 equal to 0, right? Okay, so x equal to 1, so this one's here, this is 0. All right, and then this is 1 minus 0 over 1. All right, so this is 1 minus, so it's 0 minus, so this is 0 minus, so 1 minus 0 and over 1, okay, and minus 1. Okay, so now let's take a look at here. Okay, let's resubstitute. It's a bit very careful here. Okay, so this one here, okay, so we need to be careful. Don't make a silly mistake. So this is 1 minus 1. E to the 0 power is 1. So it's 0 over 1 is 0. Minus 1 is -1, but with the absolute value is the natural log 1. So the whole these things become what? becomes zeros, right? And these things become zeros, right? So let's take a look at what we have here. So this is 0. So this is 1 minus. Okay, so this is 1 minus 1 equal to 0. So here, this is the whole, these things here is 1 minus 1 over 1 minus 1, right? Because so it's 0, so it's negative 1. So the whole things will be 0 minus 1 equal 0 plus c. So I know my c is equal to negative 1. So here. All right, so my final answers here. Okay, so the final answer for my solution is kind of a complicated. So my final answer will be negative ln x minus ey x minus 1 plus 1 over x minus ey over x minus 1 is equal to the natural log x, right? So be natural log x, c is negative 1 minus 1. All right, that's it. All right, so that will be my solutions here. So this problem looks like a very simple problem, but in fact, we need to use the substitution twice. After substitution twice, then we finally be able to do a separate variable separations and finally solve it and then plug in the initial value. All right, so this is a very interesting problem, and I hope this help you when you try to solve your this equation. Have a good day, and if you have any questions or you have a different way to solve it, please let me know. Okay, so talk to you later. Have a good day. Okay, bye.